So we're going to do a third and final law, and this is the one we're going to use most. So again, we'll prove it using the pure mathematics, but it'll be the application of the law that's going to be more powerful. So we're going to do the same strategy that we've used in the other previous two proofs, in that we're going to replace the m with something, with our thing at the beginning. So again, we're going to replace m as the answer of a to the power of b. So let's go back to where we are. So this is log a to the power of b being raised to a new exponent. Recognize this is a different n. This is a small n. It's not the capital N. Those are completely different letters. Okay, in mathematics, a capital N is completely different than a small n. Okay, so this is just some exponent. What rule do you think I'm using here? What exponent law am I using here when I have a to the b, which is then raised to the power of n? Right. This is where we have one base and two exponents, so you multiply those exponents. So this changes to log a to the a b times n. So the exponent law says when we have one base and two exponents being raised to two exponents, we can multiply those exponents. Different than the other one that says if you have two powers separate with separate bases, then you multiply them, you add the exponents. This is one single exponent being raised to, or sorry, one single base being raised to two exponents, you multiply those. Okay, we'll reuse the property of yesterday, because this is asking what exponent do you put on a to get this power. Well, obviously it's right there. So this is bn. So bn just means b times n. Because it's b times n, I can change the order around, right? N times b means the same thing. The only reason I'm doing that is so that I can resubstitute for b. Going back to my original statement, for the third time, I'm replacing b with this logarithm, log m base a. So this becomes n log m base a. So at first glance, this one doesn't look as obvious as the others. But it's probably the most important one that we'll use. This says if you were taking the log of some number that already has an exponent, that exponent can come out front and be multiplied by the other log. If you stop and think about it, that kind of makes sense, because remember, logs are asking for exponents. Well, if I'm taking the log of something that already has an exponent, that exponent can come out front. And all I got to do is figure out the rest of the log. So you see that n is moved out front. And that's going to be a big, big, big important step in our next lesson. So this one is called the power law. So log m to the n base a. So you're taking the log of something that already has an exponent. That exponent can come out front and be multiplied by the rest of whatever's left over. Because it's kind of saying you already got half your answer. Remember, logs are asking for exponents. Since you already have part of the exponent, we're going to bring that out. and bring it out front, and then you can just go off and explore the rest of it to try and figure out the rest of it. So probably the most important one, the one that we'll use most often. And again, we're going to see it with a couple of numeric questions or answers. So first off, again, we're just using the rule. So here I am, I'm taking the log of a number that already has an exponent. That exponent can come out front and be multiplied by the rest. So this will end up being the same as 9 log 8 base 10. Again, this is just applying the law. It doesn't really make this question any easier. It's just practicing using it. Of course, it works in both directions. That means if you have a number out front that's being multiplied by a log, that number can go up into the exponent. So this is 2 times a log, so that 2 can come up as an exponent. It works in both directions. So then this is the same as log base 10 of 5 squared, or of course log base 10 of 25. Sometimes it'll make your question a little bit easier, sometimes it won't, but at least it's now put together. Instead of having this 2 out front, it's put inside of the logarithm. Where will it be helpful? Maybe sometimes in a question like this. So just for kicks, can someone type in the square root of 125? Five root 5? 11.18, right. So this is asking, what exponent do I put on 5 to get 11.18? I don't know. That's going to take a lot of guessing. Okay? So maybe there's something I can do to make this question a little bit easier, so I can actually figure out an easier number. So first things first, notice that I'm taking the square root of 125. I can change that, just like in the warm-up that we had before. I can change that square root into 125 to the power of 1/2. Right? Remember, the square root of a number can be changed to an exponent to the 1/2. Why would I be interested in doing that? Well, now I can use the power law that I just looked at. It says I'm taking the log of something with an exponent. So that exponent can come out front. So I'm going to bring it out front, and it becomes 1/2 log 125 base 5. Why is that a nice move? Right. What it left us with was a log 125 base 5. That number I might be able to figure out. This asks, what exponent do I put on 5 to get 125? So it's 3, right? 5 squared is 25 times another 5 is 125. So this whole thing here, that I can evaluate. I couldn't evaluate this one because it was a nasty number. But I've been able to change this and say, okay, this is just 3. Log 125 base 5 is 3. What exponent do I put on 5 to get 125? And now this is a simple math. It's just 3 over 2, which is like 1.5, right? So let's test it out, see if we did this right. Go back to the original. Remember, the original was asking, what exponent do I put on 5 to get root 125? So let's go and do that. Do 5 to the power of 1.5. Punch that in your calculator. 5 to the power of 1.5. What do we get? 11.18. And now do the square root of 125, and we should get the same number. Okay? And technically, we did all this without our calculator. Now, you might have used your calculator to confirm that 5 to the power of 3 was 125, and that's okay. So what's going to happen is later on I'm going to ask you to try and demonstrate how you can do this without a calculator. And that means I want you to go and use the laws of logarithms to simplify your work into more manageable logarithms so that you can get an easier answer. You might use your calculator to do some of the testing, but you're not just going in and punching the original question into your calculator and spitting out an answer. Okay?